This is Garfield College in Bracknell, which has around 1,400 students from the ages of 11 to 19 years old. The college was opened in 2010 and has impressive sports facilities like this sports hall here, where the first UK Bosch Climotion system has been implemented. As well as being used for basketball, badminton and other sports, the hall is also used for examinations during the summer months.
Here in the sports hall it was difficult to control the environment for the sports teachers, especially during the ordinary PE day and during exam periods, keeping it either cool during hot weather or heated during cold weather was a nightmare as well, with children in a static situation, and they're vastly different uses for the one space.
The problem with the room currently, with the existing BMS system in play, is that we have very high airflow rates coming into the room. This causes drafts, it causes discomfort, and it causes poor temperature control. As being a control engineer for 20 years, I see a lot of buildings and I see a lot of problems inside buildings. The opportunity to be as a visitor to Garth Hill and coming into the sports hall, it was apparent to me that there was similar controls issues that I see numerous places. Being fully aware of the Bosch Climotion solution, I took no time at all to propose to the governors of Garth Hill that there could be a much better solution for the sports hall.
The objectives are to keep the pupils in the most optimum learning environment for them. We do that as cost effectively as possible, and the new system is helping us to do that.
Conventional control systems generate directed airflows. This often means that the air in the room does not mix in the most effective way. This results in temperature stratification, cold pockets and drafts. In addition, these systems require comparatively high volumes of fresh air, cooled in the summer and heated in the winter, to be supplied to the room. This results in a poor indoor climate and frequently high energy costs. In contrast to conventional control systems, the innovative Bosch control algorithm works with omnidirectional air currents that are distributed evenly across the room. This results in an even temperature distribution and ensures that the entire room is ventilated. High temperatures under the ceiling, which lead to heat loss, no longer occur, and cold, descending air next to large glass facades is also a thing of the past. By mixing the supply air with room air in the most effective way, the temperature is kept consistent across the room and drafts are prevented.
HVAC systems are challenged with balancing the need to provide occupants with an optimal amount of fresh air to satisfy the oxygen requirements, while achieving homogeneous distribution of air at the required temperature without creating drafts. We introduced artificial fog into the sports hall. This is to show how with a conventional BMS solution, the fog is caught by the supply air and immediately rises up to a high level before being extracted. This shows that a percentage of the conditioned supply air is immediately extracted before it has offered any benefit at all to the sports hall. With a conventional system, the mixing of supply air with the existing air in the sports hall can only be achieved using high air currents, causing drafts. Using Climotion inside the DDC 4200 controller from Keybach and Peter, the previous pattern of air currents are changed. The artificial fog moves in all directions to fill the area without layering or pockets forming in the roof space, thanks to the immediate and homogeneous mixing of the supply air with the existing room air. This has the effect of providing a uniform temperature over the entire space, with no dependence on high air currents that we know would cause the original and uncomfortable drafts. Very little temperature stratification between the floor and the ceiling results, because we are utilising all of the heat energy accumulated at the roof space and redistributing it over the remainder of the volume of the room. We will now blow more fog to demonstrate the effect of Climotion more clearly and facilitate longer visibility. In a very short period of time, the fog distributes evenly and with ever-changing direction throughout the sports hall. Especially impressive is the improved air distribution very close to the floor, which you can see here with the use of a halogen lamp. Without a dependency on fast-moving air, Climotion uses far less electricity. The highly efficient and total mixing of all the air in the space happens naturally, and because of this process, we are also able to realise very stable and uniform conditions in any size of room. These are clearly some of the other significant benefits to the system, which can be key drivers for other building owners or facility managers. For example, a production manager for fine tolerance manufacturing could see improvements in accuracy, or an art gallery that needs to ensure the correct humidity for protecting against high and low moisture damage will be highly motivated to secure a high level of confidence in their environment. During that test, we would have observed a massive reduction in the fan speed between the two tests. In the first test, the fan would have been running almost at 100% to deliver the air into the room. Under the Climotion system, we would have been running the fan at around about 18 to 20%. We then were able to demonstrate a saving of over 82% in electrical energy and a saving over 50% in cooling energy.
We monitor energy use here at Garfield College through remote monitoring and through the BMS systems that we have currently. It shows us on an hourly, weekly and yearly basis compared to last year and the year before how we're doing, and there's been a significant drop within this zone with the new system.
Buildings account for 40% of our energy consumption and are a large source of carbon emissions. The air conditioning and ventilation systems in commercial buildings offer huge energy saving potential. The innovative Climotion technology from Bosch Energy Building Solutions is already successfully in use in over 1,500 installations worldwide in the industrial, retail and commercial sectors, as well as in public facilities.